Hello, in this video we're going to look at a production function of the following form, and we're going to do a sample test question with multiple parts. A firm can produce a product based on the following production function. This production function is a function of units of capital K and units of labor L. We want to calculate the average product of labor when the firm uses 81 units of capital and 16 units of labor. First thing I'll do is take our production function, and for K, I'm going to plug in 81 for 81 units of capital, and for L, I'm going to plug in 16. Plugging those values in the production function, and now simplifying. 81 to the 3/4 power is 27, and 16 raised to the 1/4 power is 2, and then multiplying 10 times 27 times 2, we get an output of 540. Again, we want to calculate the average product of labor, which is output per worker. So average product of labor is simply the output divided by the units of labor. So we have 540 units of output being produced by 16 units of labor. On average, each worker produces almost 34 units of output. Our second question here, same production function. We want to calculate the marginal product of labor. So here we got to use a little calculus. We're going to take the partial derivative of this production function with respect to labor. So doing that, we're going to take this 1/4 here on the L term, bring that down in front. And then we're going to subtract 1 from that exponent on the L term. And so simplifying, 10 divided by 4 is a 2.5. We don't have to do anything with the K term or its exponent. And then L to the 1/4 minus 1 leaves us L raised to the minus 3/4 power. Simplifying a little bit here by moving this L to the minus 3/4 into the numerator, we get the following result. So that is the marginal product of labor. The next question, which is related to question B, is calculate the marginal product of labor for 16 and 81 units of labor, assuming that capital is fixed at 16. So when capital is fixed at 16 and the firm uses 16 units of labor, we're going to plug those values into the marginal product of labor function, and we're going to simplify, and we get 2.5. For K equals 16 and now L equals 81, so holding capital still fixed at 16, but this time what is the marginal product of labor if we're using more workers, or 81? Here, the marginal product of labor for the 81st worker, making our substitutions, is going to be 0.74. And our last question here, same production function. We're told capital is fixed at 16 units. The firm sells its product at a price of $100. How many workers should the firm hire to maximize profit if each worker is paid $25? So we're going to set up the profit function, which is total revenue, the price times quantity, minus the variable cost, the wage times units of labor, minus the fixed cost. We don't have any information on the fixed cost, so I'm just going to write minus fixed cost here. This is a constant anyhow, and it's going to drop out of the analysis, as you'll see in a moment. So getting total revenue, which is price, $100 from the question. What is Q? I'm just going to substitute in the production function. Q equals the following, plugging that into brackets. The next step is the wage, which is 25, multiplied by units of labor. Now simplifying some more, we're going to plug in for K, we're going to plug in 16. Capital is fixed at 16. This is a short run type problem. So plugging that in, and now we're going to simplify here a little bit. Simplifying in the brackets, and simplifying some more, we get the following profit function. When capital is fixed at 16, the price is $100, and workers are paid $25. Just rewriting that last result. Now we're going to maximize profit by taking the derivative of the profit function with respect to our choice variable. And what the firm has choice of is the number of workers. Capital is fixed at 16, so we can't adjust on that margin. We can adjust the number of workers. So we take the derivative of the profit function with respect to L. This 1/4 on the exponent comes down in front. We're going to subtract 1 from that exponent on the L term. The derivative of minus 25L is just minus 25. And the derivative of fixed costs, which is just a constant, is 0, so it drops out of the analysis here. We're maximizing, so we set this derivative equal to 0. Now we're going to solve this expression for L, but let's simplify first. So 8,000 divided by 4 is 2,000. Simplifying the exponent on the L term. Going to move this L to the minus 3/4 into the denominator. Going to cross multiply. Dividing through by 25. And now raising both sides here to the 4/3 power. L equals 80 to the 4/3 power, and that simplifies down to almost 345 workers. That is the profit maximizing number of workers to hire. Okay, I'll stop here.